Good afternoon, everyone, and yeah, thank you for coming all the way up here to the third floor. My name is Rob Knight, and I'm a technical strategist for SUSE. It's my job to help our guys in EMEA out in the field with our application delivery and platform products.
All right, my name is Peter Anderson, and I have a similar role to Rob. I'm also an EMEA technical strategist. I'm working more top-down with CASP and CAP.
And yeah, so today we're going to talk and actually show a little bit of the kind of day two activities or things to be aware of with SUSE CaaS Platform. Yeah, we're going to start off by talking about the update process, just kind of how it works in the transactional update world. And then Peter's going to talk about how to configure CaaS Platform for LDAP and setting up private registry mirrors through it. And then I'm going to demo on a lab system deploying Prometheus and Grafana for monitoring both the cluster itself and potentially any applications running on top of that. But first, just quickly, kind of why schedule. We decided to run this session. Out in the field, it's kind of one of the number one questions that I get. At least, even though we have a lot of this stuff documented, and every single command that I will be running today is available in our official documentation. Sometimes there's questions around what does this command mean? What are you actually doing? So the idea being walking through it while talking about it might help kind of clarify some of that. But also because with these these newer products, there's an entirely kind of different paradigms involved when it comes to things like monitoring and how we do things, especially when compared to how we used to do things in the world of VMs. So getting an understanding of that's important. Plus, we've got a lot of people who have tried CaaS Platform, some who have even bought it, and we kind of want to help people get the best kind of value for money out of it as they can. So first, just a quick word about the transactional update process. It's probably one of the biggest questions we get at the moment. A lot of people are aware that at the moment we have a read-only file system with SUSE CaaS Platform, or more accurately, SUSE MicroOS, and they wonder how that works. I will put a big footnote here and say, we're currently thinking about how to improve this experience for some of our customers, and I recommend you all go along to the product management roadmap session to hear all about those exciting improvements as well, to get more detail on this. But just a really quick two-slide overview. We use ButterFS, and whenever there's an update available, what fundamentally happens is we create a clone of the current live snapshot. We then change that read-only clone to read-write, and then we go into that snapshot. We true into the snapshot, and then update all the packages using Zipper, just like we normally would. We then change that snapshot back to read-only again. At this point in time, the cluster is still working off the current live snapshot. It hasn't actually applied those updates. That new snapshot that was created is marked as the next default boot, so that when the node is then rebooted, it reboots into that snapshot. And that's then, as we see at the bottom there, yes, ButterFS set default. That's it from the update side. As I say, some changes we're making in that area, so didn't want to dwell on that too much. Peter's now going to talk us through a little bit with regards to Velum and LDAP. So Peter, what is Velum?
Yeah. it's what you see here. It's a graphical interface to update and managing your CAP cluster or CaaS cluster. It can do a couple of things, install new nodes, bootstrap them, and also possible to update them and do other configuration tasks. So this works. If you push that button there, it will be updated using the process that Rob just described. And then you can update the nodes as well, the master nodes and the cluster nodes. All right, please go to settings. So first I'm going to talk a little bit about registers. So when you created your cluster and you want to use it, you are using images that needs to be downloaded and started. So and most likely you have created them yourself or got them from another source, like a vendor. My former employee provided their code or the system as a image that you get running. So what you can do is create your own registry and use that. So you push the button, add remote registry. So you can do that. So you can see what you can enter. So it's rather simple. Just give it a name and the URL to it. So super simple. One neat feature is that mirrors, because the registry might be a single point of failure. So if you have one place where you have all your images and that goes down, or you have some network issues or whatever, it might be a problem. So what you can do is make sure that you have copies of the images somewhere else in your environment and use mirrors. So if you push the add mirror, you tell which one of the registry that you created before is the mirror of this one. No, the opposite. This is the mirror of that one. Yeah, so you enter the name and the URL as well. And if you have your own self-signed certificates, you can update them as well to make sure that the communication and certification process is working. So you just update or upload a file here. Next thing I'm going to talk about is LDAP, because in most large environments and enterprises you're using some kind of centralized login system, and LDAP is more or less the de facto standard. So what you do is create an LDAP connector and give it a name and then where it is. And remember, LDAP and TLS is quite sensitive when it comes to resolving names and so on, so you must have a proper DNS setup. So make sure that you have using full qualified names and that backward and forward resolving is working properly. And the rest is probably something you touched before if you are using LDAP, so you enter the data in here. And there is a nice, neat button at the end. If you go down a little bit. Test connection, that's also very good when you troubleshoot and figure out what is going on, and so on. So these users are only used for managing the cluster. That is not application that is running in your containers. It's only your cluster configuration users. So that's what was my part. Okay?
Yeah. Thank you, Peter.
Thanks.
I think one of the things when we initially talked about this session that wasn't in the code yet as well is OIDC providers. So in terms of external authenticators, such as GitHub, for example, we can set these up in the same way that we can LDAP servers as well, making that super easy to bring in your corporate users from Google Apps or wherever as well. Okay, so now I'm going to talk and try and deploy the kind of the standard monitoring stack. As I mentioned, this is one that's available in our documentation, and it's Prometheus and Grafana. So Grafana is there to visualize the data that's processed by, or I should say, scraped by Prometheus. there's a few kind of different components involved. When we deploy this, Prometheus will run like what's called a node exporter on every node, and that's going to export, statistics about that node, disk drive status, all sorts of hundreds of different metrics, and then store them in its time series database. And then Grafana, we're going to deploy that, attach it as a data source, and then pull in that data. But one of the things that we actually have to do before we do any of that is obviously Prometheus needs somewhere to persist its data. So I've actually set up an NFS server external to the cluster, and we're going to deploy what's called the NFS client provisioner. Now, what this is going to do is create what we call a storage class. So storage class is just effectively providing a pool of available storage that an app can then go in or a developer rather can then go in and request. So Prometheus will request that from our NFS provisioner, and then the NFS provisioner will create some folders on the NFS server for that. I should kind of highlight at this point in time we only for CaaS Platform fully support with full L3 support within our SLAs SUSE enterprise storage for dynamic storage. It's best effort support for NFS dynamic storage at the moment, and that's purely because the upstream provisioner itself is still in beta itself. We'll try our best to the support team to help, but there's no guarantees like there are with SUSE. But I personally don't know how to set up SUSE, so I'm the Kubernetes guy. So we got a command there which we can see there. Going to be using a Helm chart to deploy this. Makes it super easy to actually get up and running. For those unfamiliar with Helm, it's a kind of a package manager for Kubernetes, and all of the kind of Kubernetes manifests and YAML files. It allows us to template those and ship them, and it's how as a vendor, someone will probably package up and ship their application. One of the cool things about Helm, we'll see here, there's a file that allows us to override default values, like environment variables. And this file here, if I load this up, NFS client values, we'll see that all this is doing is just providing data into the NFS provisioner as environment variables. And in this case, it's got the location of my NFS server and the path that it's using. So when we see a values file like that, and we'll use them later on during the Prometheus and Grafana bits, that's what it's doing. So I'll go ahead and run that. And then it will come back, hopefully saying deployed. Great. So yeah, we can see here it's created a service account, a cluster role, various RBAC privileges.
Rob, can you move the screen a little bit to the right? Yeah, a little bit. The window, because it's cutting.
That better? Hang on.
I had the same problem, so I didn't use full screen. Oh,
There we go.
that doesn't help. Just move the window a little bit to the right.
Well, that's the...
Okay, that's full now. That's good.
Thank you for pointing that out, Peter, because I would have had no idea. So it's created a bunch of RBAC stuff, deployment, and also that deployment has itself created some pods. We can see if that's ready by doing kubectl get storage class, which is abbreviated to SC here. And we can see here, yeah, I've got a storage class that's available. For those familiar with Kubernetes deployments, when to use a storage class instead, during our PVC, our claim, we just reference the storage class name instead of referencing the volume, which is what we would have done with static storage, just as some kind of side info. Going to go and create a namespace now called monitoring. And this is where all of my my monitoring components will exist. Obviously, the namespace already exists, probably from when I was preparing this earlier. The next thing that we're going to do is I've already generated SSL certificate and key. And obviously, in the case of your organisation, this would be your ones that could be signed by your own organisation, or could be Let's Encrypt, or something like that. And what we're doing is basically taking the certificate and key, and then we're turning that into a Kubernetes secret called monitoring TLS. I'll explain why we need this in a minute. But that's all it's doing is taking those secrets and putting it in there. Those two, fortunately, already exist in my monitoring namespace, but it would have just said success if otherwise. Now, the next thing we've got to do, we've got another Helm install, and this is for the Nginx Ingress controller. Now, Ingress is a way for us in Kubernetes to help our developers when it comes to managing network resources. So as kind of a cluster operator, I deploy the Ingress controller, and in that controller I would deploy, say, my corporate certificates and my corporate configuration, and then developers can, just like with storage, request an Ingress object. When they then do that, it will allow me in the browser at the top to type Grafana my fully qualified domain name, and then the Ingress controller will route that traffic to the right pod, or to the right back-end Kubernetes service, I should say. It can be used for both stuff that you're trying to get into the cluster externally. So if you're deploying CaaS Platform on bare metal, it's a great alternative than using node port services. Because in addition to that, it can also provide us with load balancing capabilities, and we can do canary testing and things like that, as well as kind of create basic service meshes as well. But for this purpose, it's purely to get traffic in, so I don't have to use a node port. The Ingress controller itself for this deployment will actually be running on a node port externally, but we'll talk about that in a second. Now, that's now just like before. It has it's deployed my Ingress controller. Now, the Ingress controller, we actually provide one and support one as part of SUSE. This isn't some kind of random third-party one that's out there. You can get help and support with that from us. It's one of the newer things that we've done. And what I'll do is I'll show you as well that config values file that I created earlier on, and that was purely saying what port was that the controller was going to listen onto. So when I go to any of the worker or master node IP addresses in my cluster, and then hit port 3443 or 30080, it will route traffic to my Ingress controller. But the Ingress controller will only respond to requests that have the correct FQDN. It uses the SNI provided to it by Google Chrome to see what address I've gone to. So if I were to go to just the IP address rather than grafana.home.rob-knight.net, it would give me an error page. But we'll talk about that a little bit more later on. You can also deploy an Ingress controller, with the object type of load balancer. So if you're running on public cloud, that's a great way to do that. I could actually do that on bare metal if I wanted to, because I've got Metal LB deployed. And if you are running on bare metal, I do recommend looking into Metal LB as a third-party way to kind of provide on-premise load balancer support. So next thing I'm going to do is create another secret. And what this is basically doing is I've created an AUR file. And all this is, as you know, sysadmins will recognize as the standard Apache config format. And this is just providing a username and password credential, which is going to preface our web services. It's probably going to say it's already there, which it is from earlier, so we've got that secret deployed there. And now we're going to go ahead and deploy Prometheus. I'll show you my Prometheus config value file really quick. In it, we are describing what services we want enabled. So alert manager, so if you want alerting, it can do things like send notifications to my Slack, for example. We have that enabled there. I'm telling it in the next line down to use Ingress as opposed to using its own service type, node port, or something like that. And then further down, most importantly, I'm telling it the name of the storage class that I want it to use. So that's the NFS-based storage class that I had deployed earlier on. That's the section for Alert Manager, and further down, we've got exactly the same for Prometheus. We want to enable the node exporter. It's what generates kind of host level statistics, as I said, CPU use, RAM use of the underlying Kubernetes host, which is great. And then finally, the configuration for Prometheus itself. So, the host name that it's going to respond to. And then what I've got to make sure I also do is in my DNS server, this prometheus.home.decana that is obviously where my Ingress object is going to live. So I need to make sure in DNS that name resolves to my Kubernetes worker or master nodes, because it's going to hit those first, and then the Ingress controller is going to send the traffic to the right backend place. Right, I go ahead and run that. It'll take a couple seconds. And we can see again, deployed a few additional things here. Again, some RBAC information. We can see there it's deployed the Ingress object up there. Created a service account, created a deployment, a bunch of pods as a result of a deployment, a config map. So for those unfamiliar, config map is how we can pass configuration data to our applications in Kubernetes, and a couple of services as well. And most importantly, the node exporter is running as a daemon set. And for those unaware, daemon sets will run a copy of that pod or workload on every single node in the cluster. And as I add new nodes, it will make sure that that node exporter is also deployed onto to those nodes as well. Now, next thing I'm going to do is I haven't yet deployed Grafana, but I'm going to tell Grafana where to point, and telling it to point at Prometheus. I'm creating a config map, as we can see here. And interestingly, just to kind of note, I'm using the Kubernetes internal service discovery there to make sure that it uses the internal network fabric rather than going out and trying to use the Ingress controller or anything funny like that. But you don't need to change any of these values from the documentation. The defaults will just deploy fine. The only ones that you do need to change are the host values that were on the other one, because those are specific depending on what FQDN you want to use. So that data source is now deployed. And second to final, I'm going to deploy the Grafana Helm chart, pointing to my Grafana config values file. The Grafana config values file is very similar to the Prometheus one that I showed earlier on. It's the most important field in there is the host name that you want, or rather the Ingress object host name that you want it to use. Right, so that's all deployed now. So now, if I get pods, I should be able to see most of the stuff should be ready. That's great. The only thing that's not there is my Grafana pods are still initializing. Now they're now up. I should now be able to see if I get the list of Ingress objects that exist, and I should be able to view Grafana at that address. Let's try getting to Prometheus first. Although it does say on the right there that it's running on port 443, I actually changed my Ingress controller to deploy to a slightly different port. The Ingress controller is running on 3443, and that's just because I deployed some of our other products which already use that port, so I needed it to run on a different port. And this is the self-signed certificate that I was passed in earlier on. And this here is the authentication created from the Apache auth config file earlier on. And voila! So yeah, so we've got Prometheus up and running. If I knew how to query in PromSQL, then I'd put stuff in there. But a much better way to display the data is obviously to use Grafana. Inside our config values earlier, obviously we had a set of default credentials, which I've used there. Just make that a bit bigger. Now, initially, there would be no dashboards deployed. If you follow the documentation verbatim, you wouldn't actually have any dashboards there. What we need to do is there's some that are available in a repository that we publish inside of the Cubic project, our upstream project. Is I've checked all of those out, and they're just a series of config maps that I can go in and apply. If I show you one of them, they're very long, but yeah, they just simply describe all of the graphs that Grafana is gonna draw for us. There's 4 of them that are deployed. We can go in and we can view individual node data. There's 3 nodes in my cluster there. And see CPU use, all sorts. I can also get that data cluster wide as well, and get various statistics that this has pulled out from the cluster. And this is mainly because Grafana doesn't ship with any kind of default dashboards. We need to apply these ourselves. There's loads available from Grafana.com for all sorts of different kind of different products. And obviously at SUSE we're starting to use Grafana across a lot more of our products. Soon we're going to get those capabilities within, say, SUSE Manager. We've already got them inside of SUSE Enterprise Storage and inside of the Monasca project with cloud, as well as the metrics within SUSE Cloud Application Platform as well. When it comes to actually deploying your apps, obviously there's no kind of application-specific stats here. I can get details about the pods and the nodes. That's largely up to your developers. A quite common situation. They'll make their stats available over a metrics port, along with their application within the same container, and all depending on what kind of system we're using, Prometheus can go and scrape that, or we can use a sidecar container to ship that off to another time series database like InfluxDB, for example. But just out of the box, we get the kind of the cluster monitoring that's available there. Using Alert Manager, we can kind of set up alerts. But yeah, as I say, it's up to developers themselves to figure out what monitoring works best for their app. And as an ops team, you provide the monitoring infrastructure of Prometheus and Grafana, and then it's up to the developers to go ahead and consume that. Just like anything else, when it comes to Kubernetes, you provide the platform or tool or class, and then it's up to them to consume it. So that is largely it. As I say, all of those commands are available in the CaaS Platform administration guide. There's a section on there on monitoring. There's another section, I think, on logging as well. The final slide that I had up was a slide saying Q&A. So, are there any questions? Cool. So that's everything. And yeah, thank you all for coming.